for the second derivative of a parametric curve, we'll write it just like you did last semester. D squared y, I said it's second derivative of y, over with respect to x squared. So there's the notation for the second derivative. It is the derivative with respect to x of the first derivative and then dy over dx, that's first derivative. Here's what you need for this. It's the derivative with respect to t of the first derivative divided by the derivative of x with respect to t. So for the problem I just did, I want to go ahead and find the second derivative. Let's see, the one we just did was x equals t squared and y equals t cubed minus 3t. We'll find the second derivative with respect to x. So for that, yes?
Oh, I'm kind of confused on what that middle part is, the dx times the first derivative.
That's just saying the derivative with respect to x of the first derivative is the second derivative. Okay, thank you for asking. All right, so the first derivative was, or is, 3t squared minus 3 over 2t. I might need to rewrite this a little bit. I'm thinking for the second derivative, I have to do the derivative of the first derivative. So as I'm looking at it right here, my mind kind of said quotient rule. And then I said, wait a minute, it doesn't have to be that hard. Right? Because I could rewrite this. This is 3t squared over 2t minus 3 over 2t. So the first derivative is 3/2 t minus 3/2 times t to the negative 1. Right? Here's the first derivative. So when I do the second derivative, I probably want to go ahead and use this version of it to do the derivative of the derivative for the numerator. So I'm going to go to a new page for this. The second derivative is the derivative with respect to t of the first derivative over the derivative of x with respect to t. I'm going to fill this in, although you might not need to see this filled in. The derivative with respect to t of 3/2 t minus 3/2 t to the minus 1. And what was dx over dt? That was 2t. So now the derivative with respect to t in this numerator, that's going to be 3/2 plus 3/2 t to the minus 2 over 2t. So there's the second derivative of this parametric curve. Okay, you can simplify it. I'm gonna leave it like that because I'm not planning to do anything else with that problem at this point.